Hi everyone, this video will go through our in-class framing worksheet. If we didn't get through all of the examples in the lecture, or if you are doing the homework and have questions, this video will go through all of the problems on the example worksheet in detail. Here's our framing plan, and this plan has several different types of spaces. It's the plan of an office building. We have open office spaces. We have storage spaces, lobby spaces, and corridors. We also have different types of spans. Most of the spaces are one-way spans going in different directions. We also have a two-way span in the southwestern corner of or southeastern corner of the project. There are also several spaces that are open to below, and there's not a floor here. That will be easier to explain if we look at the 3D diagram. So this is a 3D view of the floor plan, and you can see here that there are two moments where we have void spaces, and the one on the right has a stair, which will be shown in the next drawing. What we're looking at now is the floor slab grayed out, and we're really looking at an X-ray view, which is showing all of the framing members below that slab. And if we take the slab off, then we can see all of those members, and the stair appears here. And you can see that for our one-way spans, these blue beams indicate the direction of the span. And then in our two-way span, we have a grid of beams indicating that the load behaves differently. In this system, we have green girders, blue beams, and red columns. The blue beams are just here for reference. We're not going to get into the fine-grained detail of calculating the tributary areas for beams. We're only going to be looking at the girder and column level. And the beams are just here to give us a visual indication of which way the one-way spans and the two-way span are running in the system. This diagram shows the tributary areas for all of the girders. Now, of course, these individual beams would also have tributary areas, but we're not looking at that level of detail in this series of questions. We're just going to be looking at the loads on the girders and at the tops of columns. So this diagram shows us all of the tributary areas for our girders. If we look at those tributary areas as a series of continuous loads, this diagram shows us what this looks like. And so the tributary area for this load coming to the top of this beam, for example, gets represented in this diagram as a series of continuous, or as a continuous load running along the top of the beam. We also have some arrows in the system, and these are indicating locations where we have point loads. Here are all the point loads with the continuous loads turned off. We have point loads where girders are resting directly on other girders and not on the tops of columns. Most of our girders span from side to side and land on columns, but we do have three girders, this one, and this one, which rest directly on girders, and there are no columns below. And the result of this is that these girders will deliver point loads at the places where they connect with the girders that support them. And that's what we're showing with these arrows. All right, this is our first example. Example 1 asks us to calculate the load on girder G1, determining the beam reaction of G1 at column A2. And what we mean by the beam reaction of G1 at column A2 is how much load is the beam delivering to the top of that column. So let's locate G1 in our system here. So in plan, we see G1. So that's referring to this girder. So this is the girder going from this side to this side. And we're also asking about column A2. So what is the beam reaction of G1 on column A2? And so we read a column framing plan just like the game Battleship. We're going to have letters in one direction and numbers in the other. So if we talk about column A2, we're looking for the bubble that says A. So this would be the row of columns A. And then we also at the top have a vertical row of columns indicated with 2. So A, 2, and this is the column that we're interested in. Okay, so the question is, what is the total load on girder G1, and then how much load is this? Sorry, this drawing system's a little tricky, but there we go. How much load is coming to the top of column A2? So here's girder G1 in 3D, and here is column A2 in 3D, and we need to figure out how much load is coming here. Well, the first thing we want to figure out is what is the tributary area for girder G1, and that's shown in this diagram. And we also then need to know what are the live loads and dead loads per square foot in this space. And we have that indicated here. The dead load will always be 95 pounds per square foot, and the live load will vary from space to space. In this open office space, it's 80 pounds per square foot, for a total load of 175 pounds per square foot. All right, so so that's where this area is in plan. And let's zoom in and calculate the load on G1 and then find the reaction at A2. All right, so tributary area for G1. Let's identify that first. It's going to be half of this space, right? And let's kind of sketch that out here. So all of this zone is going to be the tributary area. This is going to be the area that we're interested in. And so we can see here that it's 24 feet wide, right? I'm sorry, the length of the beam is 24 feet. And then the span in the other direction is 16 feet, which makes the tributary area here, so we can get this thing to draw. It's a little tricky. So our tributary length in this direction is going to be 8 feet. There we go, 8 feet. The drawing tools here are not so great, but we're going to do our best. All right, so that's 8 feet in this direction, and we have 24 feet in this direction. So let's figure out the loads on the top of G1. All right, so we have the total load of let's see if I can write this. Let me pause this and figure something out here. Okay, I found the setting on my pen tablet, which should make drawing easier. So we've identified the tributary area here. It's 8 feet, and G1 is 24 feet long. So let's calculate the load for G1. So we have 175 pounds per square foot. Our tributary area is 8 feet. This equals 1,400 pounds per foot for this tributary area. And we know that the loads are going in this direction. And, right? So if we sketch a free body diagram for G1, it's going to look something like this. And we're going to visualize our continuous load going across the top like this with a load of 1,400 pounds per foot along its length, which we know is 24 feet. Okay, so we can now convert this 1,400 pounds to a point load. And let's change colors here. Oops. Let's make a new note here. Let's change colors to red. Okay. All right. Changing colors doesn't seem to be my strong suit here. So let's just go back to drawing this point load. We know it's going to be in the middle here of the beam. And this will be 1,400 pounds per foot times 24 feet equals 33,600 pounds. So 33,600 pounds. This is our point load. And we don't need to do a moment equation for this beam. So we have column A1 pushing up on this side. We have column A2 pushing up on this side. And we don't need to do a moment equation because the beam is symmetrically loaded, right? Our point load, or our continuous load, visualized as a point load, is right in the middle of the beam. And so we know that one half of the load is going to be going to this side, and one half of the load is going to be going to this side. So what is half of 33,600? That is going to be 16,800 pounds. And that's the load that is being delivered to either side of the beam. So to answer the question, what is the load on girder G1? Well, we could say that it has a continuous load of 1,400 PLF, pounds per linear foot. Or we could say that it has a total load of 33,600 pounds. That's the total load. And then what is the beam reaction of G1 at column A2? So that's here. That is going to be our, what we just calculated down here, one half of the load on girder G1. So that is going to be 16,800 pounds. So that's how this works. Now, if we wanted to shortcut some of these things, let's see if I can, let's just go back to another page. All right, if we wanted to look at this a little bit differently, so we're going to be converting things to continuous loads along the top of beams, and that's along the top of our girders, and that's helpful for keeping track of trickier situations. But for a simple case like this, we could say, well, the area under the load, right, is this square footage. And this is 24 times 8 times the 175 pounds, which is the total load in this area. And if we do that calculation, it's 8 feet times 24 feet times 175 pounds per square foot for this zone, right? That is going to give us our 33,600 pounds. And if we then think about, like, what is the load that is being supported just on G8, right? It's going to be half of this amount. We could also look at this and say, well, as far as the, I'm sorry, not the load on G8, the load on A2. So if we're thinking about, well, what percentage of this one-way span is being delivered by G1 to A2, we could also just look at this zone, and we could say, well, this is 12 feet by 8 feet. And this is going to give us our, if we multiply 12 feet, 8 feet by 12 feet by 175 pounds per square foot in that area, this will give us 16,000, what was it, 800 pounds. 16,800 pounds, which is our answer for what is the beam reaction of G1 at the top of A2, right? So you can look at this problem in several different ways to solve for it and check your work by looking at the area that's being supported by a particular girder. Let's keep moving. Let's look at now our second problem, which is asking us to calculate the load on girder G8 and find the beam reaction of G8 at column B2. So B2 is the same column that B2 is this column here, and girder 8 is this one. So what is the tributary load on girder 8? We just have a one-way span from the corridor, and we should look at this in a plan view. So this is G8. We're concerned with how much G8 is putting onto B2, and G8 is supporting, so what is to the left of G8? We have a one-way span, but it's going in this direction, so it's not resting on G8. What's happening over here? We have a one-way span going in this direction, right? Which means that half of this one-way span is going to be resting on G8. So let's go down. All right, so here's girder G8. Here's the tributary area for G8. So the portion of the corridor that's resting on it, we can see down here that the corridor is 8 feet wide. And so if we do a zoom in view here of that, we have G8. Here is B2. So this is B2. And we have this one-way span. And 1/2, so what is the tributary area for G8 for this one-way span? It's going to be 4 feet, right? So it's going to be this portion of the one-way span that is being delivered to G8, and the other half of this corridor load is going over to G9. All right, so let's draw a free body diagram for G8. All right, so here is G8. It's going to be supported at this side by column B2, on this other side by column A2. So we're looking at it in that direction, B2 on the left, A2 on the right. And what is the total load for the corridor? It's 100 pounds per square foot plus our dead load, which applies everywhere, of 95 pounds per square foot for a total load of 195 pounds per square foot. So 195 pounds per square foot times our tributary area for G8, which is 4 feet, gives it a total load of 780 pounds per foot. Sorry, that should be a foot. And this is also, per linear foot, our PLF. And so when we come to sketch our continuous load here, like this, we have 780 pounds per foot. And what is the overall length of girder G8? So this is, of course, girder G8. And what is its overall length? 16 feet long. So what is the total load on girder G8? Let's see if I can. It just changes the color of everything here. Could I start a new note? No. All right, let's just stick with that. I'm sure there's a way, but let's now draw, oops, not doing what I wanted to do. Shouldn't have tried to change colors. All right, let's see if I can, I'm starting this new note. All right, that's going to be our point load visualization of this continuous load. And what is that but 780 I've got myself into a real pickle here. 700 and, all right, let's do it down here. All right, so 780 pounds per foot times 16 feet. It's a 16. Gives us a total load of 12,480 pounds. All right, so this is our continuous load visualized as a point load here, 12,480 pounds. Again, we do not need to do write our equations of equilibrium because we have just a very simply loaded beam. It's symmetrical on both sides, which means that the beam reaction for G8 at B2 is going to be 1/2 of this load. So that's going to be 6,240 pounds. And on the other side, at A2, we're also going to have 6,240 pounds. So what is the answer for calculate the load on girder G8? Well, we can either say that it's 780 pounds per foot as a continuous load. The total load is 12,480 pounds. And the reaction of G8 at column B2 at the top is 6,240 pounds. Okay, great. Let's move on to the next example. And the next example is going to be more complicated. We did go through, well, I don't know. Did we go through this one in class? It depends on which year you're watching this. So let's look at example 3. Calculate the load on girder G2. Determine the beam reaction of G2 at column B2. So G2 is here, and we want the beam reaction of this at column B2. So, okay, so there's quite a lot of stuff going on here. Let's look at our 3D diagram. This is girder G2. One of the things we'll notice is that we have a one-way span from this side, which is the same case as the first example. And then we have a void here. So there's a hole in the floor at this moment. So this X is telling us that we have a hole in the floor, and we have one-way spans on either side of that resting on girders, which rest directly onto G2. Okay, so what are the tributary areas for girder G2? We have one tributary area from the office space to the north, which is coming in like this, producing a continuous load along the top. Then we have 2 point loads coming from girder G11 and G12. So each of these girders will have their own tributary areas, right, producing point loads along the top. They're different types of spaces. This one is a storage space, so it has a higher live load. So we have a total load of 295 pounds per square foot for that space. And then this one is another office space, so it has the same 175 pounds per square foot total load. Now, these girders have continuous loads along the top, but when we come to the ends, they distribute that continuous load as a point load where they connect to girder G2. So in the end, we're going to have our continuous load coming from the office space, as well as these 2 point loads coming from girders G11 and G12. And we need to figure out what those are. So let's do that. Let's zoom in here. So our continuous load so what are all of the loads that are, let's do our free body diagram for, so our free body diagram, if I can get that to kind of come out like that. Okay, let's see if I can keep drawing here. All right, so this is going to be our free body diagram for G2. And we have we'll be looking at it, let's say, in this direction, which means that B1 is going to be here. And that's going to be our column supporting it there. And we have B2 over here. And this is our column supporting it here. Okay, so we have one continuous load coming in from the office space to the north, and that's going to go all the way across the top of G2. Now we calculated what that load was back in example 1. It was 1400, because here's G2, this is what we're looking at now. G1 was loaded in exactly the same way from this office space. So we calculated this as 1,400 pounds per square foot along the top. So rather than calculating that again, let's just use that value. So we have 1,400 pounds per foot along the top, and that is coming from the office space. So basically this tributary area, all of that is coming along the top of G2 down here. All right, so then we have these other 2 girders, G11 and G12, which will put point loads where they connect to G2. So what is the proportion of load that we need to account for in our point loads? Well, we know that the tributary area for G11 is going to be this half of the storage space. And we know that the tributary area for G12 will be this half of the storage space. Okay, so then what is the total amount of load on G11? Let's look at the tributary area. And what is the load condition? It has a high live load of 200 pounds per square foot. We add that to the dead load, which we apply everywhere. So for the storage space, we are going to get a total load of 295 pounds per square foot. And what is the area being under load here? We're just going to calculate it all at once. Well, we have 3 feet in this direction, right? And then 14 feet in this direction, because that's 14 feet. So 3 feet times 14 feet equals, go ahead and calculate it here. So it's 295 times 3 feet times 14 feet. That's going to give us a total load on G11 of 12,390 pounds. Now this total load is like the point load, right? So if we were looking at G11, a little free body diagram of G11, what we would see here is now that is the point load version of the load, right? If we were thinking about the continuous load along the top, it would only be 295 times the tributary area of 3 feet, right? So that would be 295 times 3. So that would be 895 pounds per foot for the continuous load, right? And then if we multiply that 895 times the length of this, which is 14 feet, then we get this 12,390 pounds. And so we have, we just jumped quickly to that value, right? Because we're trying to find out, okay, what is the point load dimension here? So if we look at the dimensions of everything on the system, if we're coming from left to right here, we now have a point load from G11, which is 12,300, and oops, that is wrong. Hold on real quick. Let's go back and erase that. Because in fact, this is the total load, right? Which means that half of the load, oh boy, let's see if I can, there we go. Get back to half of the load is going to be going over here, and half the load is going to be going over here. Which means that if we divide 12,390 in half, so 12,390 divided by 2, that's only 6,195 pounds. 6,195 pounds going to either side, right? So let's look at that, 6,195 pounds. Let's put that in our free body diagram up here, and that's from G11. Okay, let's look at G12. So G12, that is another office space. So let's call this office number 2 down here. And so we have this 80 plus 95, so 80, 95, that's our 175 pounds per square foot for our office spaces. And then what's the area under load? The tributary area here is half of 11, so 5.5 feet. This is going to be times 5.5 feet times the overall length of this girder, which G12 is 14 feet long. And so what does that end up being? So it is 175 times 5.5 times 14 feet. That is going to give us a total load on G12 of 13,475 pounds. And then we want to divide that by 2 to figure out what is half of that, because that is going to be distributed here onto G2, right? So let's just draw that point load, and let's divide 13,475 by 2. That gives us 6,737.5. That's a 3. 6,737.5 pounds. That's our point load from G12. So G12, and so 13,475 divided by 2 is 6,737.5 pounds. Okay, great. So this is, and now let's take our continuous load, right? And 14,000 pounds per foot, and put that as a point load, right? Represent that as a point load right in the middle here. And we calculated what that was in problem 1. It was 33,600 pounds. So that is 1,400 times 24 feet, the length of the girder, and we get that. So let me give myself a little more space down here. Like erase all of this stuff if I can. Hopefully this works. Kind of worked. That's not really working. Let me go ahead and pause the video for a second and clean that up. little bit cleaner. And let's put our dimensions in here. Okay, there we go. So this is covered up here, but this is 6 feet. So the distance from B1 to G11 is 6 feet. Then we have our continuous load represented as a point load here, and this is half of the overall length of the girder, which is 12 feet. Then we have the distance to G12, which is 6 plus 7. So that is going to be 13 feet. And then the overall length of the girder here is going to be 24 feet. All right, so let's now do our moment equation for this, because we're trying to calculate the load on girder G2. And so we know all of the loads on G2, and we need to find the beam reaction of this should say G2. We're trying to find the beam reaction of G2 at column B2, which is here. Okay, so let's do a moment equation for this. And let's do our moment about this point on this side, which is B1. So we're going to say the sum of the moments about B1 equal 0. And we start reading this like a book from left to right. Now remember, our moment conventions are, if we're going clockwise, we call that negative. And if we're going counterclockwise, we call it positive. All right, so with respect to B1, G11, this point load is trying to turn it this way. This one is trying to turn it this way. This point load is also trying to turn it clockwise, and it's only at B2 that our reaction is trying to go in a counterclockwise direction, which means that we're going to have negative 6,195 pounds times 6 feet minus 33,600 pounds times its distance from B1, which is 12 feet, minus our last point load, which is 6,737.5 times its distance, which is 13 feet, plus our last stabilizing force here, which is B2, and its distance is 24 feet, equals, oh, I can go over here in the gray, equals 0. And if we crunch the math on all of this, B2 equals 21,998.23 pounds. All right, so the force at this end, right, is 21,998.23 pounds. So that's the beam reaction for G2 at column B2, and then column B2 has to push back. So, right, that should not be a tick mark. That should just be the force going down, because our tick mark always shows the stabilizing reaction, and so this is B2 is going to have to push back at that. We're going to have a different load at B1, and that would be, if we added up all of these loads, 6,195, 33,600, 6,737.5, we added all of those up and then subtracted 21,998.23, that would then be the reaction, or the girder reaction at B1, how much it's pressing down, right? And that would just be us writing the sum of the forces in y equals 0, right, and figuring that out. So let's move on to our next example. But this one's tricky. This one was trickier because we had to figure out, we had to do a moment equation. Okay, so our next example, example 4, is asking us to determine all of the loads on column B2 and determine the column reaction at B2. So what we want to know is what are all of the loads that are coming into, so here's column B2, and what are the, get rid of that. What are the loads from G2, G8, G13, all of these loads which are going into the top, right? And then what is the reaction at the top of B2? Pushing back against all of those loads, right? So we're going to have half of the loads from G13 coming in here, half of the loads from G2 coming in here, and half of the loads from G8 coming in here. All right, so how do we figure that out? Okay, well, we figured out some of these things previously, right? Here is the here's the loading diagram for this column, B2. These are all of the tributary areas that it supports. We've actually figured out this one in question 2, right? We've figured out how much G, this is, I believe, girder G2 contributes, right? So the only one that we really have to figure out is G13. And that's going to be looking at some of the load cases that we've already looked at as well. So let's figure this one out really quickly. So this is worksheet example 4. Calculate all of the loads on column B2. So this is column B2. So we're trying to figure that out. All right, so what are the loads from G8? So let's look at so we know that we have to deal with the loads from G8, the loads from G2, and the loads from G13. So what are the loads from G8? Well, in one of our earlier examples, we looked at the beam reaction of G8 and found this for column B2 already. So that's going to be 6,240 pounds. So that's 6,240 pounds. Or we could write this as 6.24 kips. All right, what about the load from G2? So G2 we looked at in the last question. So the load from G2 is going to be what we just calculated, which is 21,998.23. So 21,998.23 pounds. Or we could look at this as, we could just round it up to 22 kips on that one. All right, now the load from G13. So what is the load from G13? Okay. All right, well, let's look at G13 really quickly because we haven't solved for that one yet. We know that its tributary area is going to be half of the loads from this office space. And we know the tributary area on this side is going to be supporting the one-way span from the corridor. So we have that. All right, so let's just quickly look at the total loads on G13. So from the one-way span, it's going to be the same as G12, right? So we looked at G12 in this other example, and we know that, let's see, G12, half of G12, because that's the point load that was being supported on G2, was 6,737.5. So let's just look at then this area, right? Is what's going to be supported. So that area is going to be 6,737 pounds and a half. Plus, we're also supporting half of the loads from this one-way span, right, on G13 at column B2. That's going to be very similar to what we figured out in this earlier plan as well, right? This earlier example, rather, that we know that the beam reaction of G8 at column B2 is, oh, this is not going to be the same because this is a different distance, right? This is 16 feet. So let's just go ahead and quickly calculate that for this side. So we're going to have, what's the area under load here? We have 195 pounds per square foot, because that's the 95 pound dead load condition everywhere plus the 100 pounds per square foot for the corridor, times what's the tributary area of the girder? It's going to be 4 feet times 4 feet. And instead of multiplying this by 14 feet, let's just look at the area that 1/2 of the area, because we know that that's the load that's going to be going into B2. So let's multiply this by 7 feet. Okay, so now we have 195 times 4 times 7 equals 5,460 pounds. All right, so let's add that to our overall load. So that's 5,460 pounds up here, plus 6,737.5. That's going to give us a total load. Wait, that's something I multiplied. Sorry, that looked really high. Hold on 1 second. So we're going to add. Sorry, we're going to add 6,737.5 plus 5,460. That looks better. 12,197.5 pounds. So the load from G13 is going to be 12,197.5 pounds. And we can round that up to 12.2 kips. So what's the total load on, what is the total load? If we add all of these things up, let's add up the kips. 6.24 plus 22 plus 12.2 kips. That is going to be a total load on column B2 of 40.44 kips. All right, so this solves for example 4, and we only have 3 to go. Let's look at those. All right, example 5. Calculate the load on girder G6. Determine the beam reaction of G6 at column B3. All right, so where's G6? This is this guy. And where is B3? So B is here. Our column line 3 is here. So this is B3. This is B3. This is G6. And now what we have to recognize here is that we are dealing with a two-way span. And this two-way span distributes its load differently. So the amount of load going into G6 is coming from this triangular section of the two-way span. Okay, so here's girder G6 in context. Here's our two-way span. This is how the two-way span is distributing the load. So this is the tributary area for each girder on either side of that space. And if we're looking at G6, this is the area of the continuous load that gets distributed along the top of G6. Okay, so let's look at this. G6, we're interested in where G6 comes into B3 here. So let's draw a free body diagram for G6. Here's G6. Here is B3 on this side. And here is, on this side, we have B4, column B4. And there is nothing on the northern side of G6 because we have a stairway there, there's an X, it's open to below, there's no floor, so there's no load. So what we have to deal with here is this two-way span load. All right, so how do we figure out what that is? Well, it's the area under the load. And so the area under load is going to be, it's a triangle, right? And so the height of the triangle is going to be 7 feet. And the base of the triangle is this full width, which is 14 feet. So what we're looking for here is 1/2. It's the area of a triangle, 1/2 the base times the height. So 1/2 7 times 14 feet here, right? And let's just go ahead and multiply that by our the area under the load, right? And I'm sorry, we are finding the area under the load. Now, what is the load in that area? That is 195 pounds per square foot. And what does this become? So let's multiply our areas here. So it's 0.5 multiplied by 7 times 14. So that gives us 49 square feet times 195 pounds per square foot. So the total load in this area is going to be 9,555 pounds. Right, so we're going to represent that as a point load here of 9,555 pounds. We don't show it as a continuous load because we figured out the entire area, right? So this entire area is 49 square feet. And the so the continuous load would be this divided by 14 feet. And but we're not, this is good enough for what we need to do. And so 9,555 pounds. Let's divide that by 2, which tells us that 4,777.5 pounds will be loading on top of B3, and then 4,777.5 pounds will be loading on top of B4. So that's the answer. What is the beam reaction of G6 at column B3? 4,777.5 pounds. And what is the total load on G6? The total load on G6 from this two-way span is 9,555 pounds. All right, moving right along. Example 6. What does example 6 ask us? Calculate the loads on girder G9. Determine the beam reactions at column A3 and B3. Okay, so where is G9? G9 is here. And calculate the beam reactions at columns A3, which will be up here, and B3, which will be down here. Okay, so let's do that. Let's look at the loads here. This is another tricky case because we have a, here's G9. We have the stairwell here, so we have an opening and our loads for, now with this problem we're ignoring the weight of the stair. So the stair is resting here. That would also have a load, but we're ignoring that. We're keeping these things simple, and we're just looking at the loads on the girders from the slab and the weight of the structure and the live loads. So we have this girder here to the top, which is, what is it in the, sorry, G5. So this is G5, and G5 is going to load G9. So we're going to have a point load here, and because there are no columns under G5. So when we look at all of the loads on G9, we're going to have a continuous load coming from the corridor, and then we have this point. We have a point load, right, which is coming from G5 here. So we need to figure this out. So let's look at this area. What we're interested in is G9, and we're interested in the in B3 and A3. All right, so let's draw a free body diagram here of G9. And G9 is going to, let's put B3. So we're going to kind of look at it, sort of look at it in that direction. And we're going to put B3 here, and that puts A3 on the right-hand side. So we have a continuous load coming from the corridor, right? We have a continuous load coming from this side. I should have set up this diagram so that it actually shows that we have the corridor on this side. That was not very wise of me. I'll fix it for the lecture slides. But we already know what this load is, right? Because we've, way back in one of our earlier examples, I think it's example 2. Here in example 2, we looked at the same tributary area for girder 8. And girder 9 is going to have the same type of situation, right? Which means that we're going to have this 780 pound per square foot. Per linear foot, and then a 12,480 point load. So let me just write that down. I think I already have it written down. Do I? 12,480. Yes, I do. Okay, awesome. So let's go back to the problem that we're working on here. There we go. All right, load on. So we have a continuous load across the top of 780 pounds per foot. And then we have our, we can look at that as a point load in the middle of the beam. And that point load will be 12,480 pounds. And that's going to be in the middle of the girder, so that's going to be 8 feet. Oh, yeah. 8 feet, because the overall dimension is 16, and so that point load is going to be right here, right in the middle of the beam, right? And so we get 12,480, which is simply 780 times the overall length of the beam, which is 16 feet. All right, now let's figure out G5. So we have G5 here. And what is the load contribution of G5? So what is the total load on G5? Well, it's going to be half of this storage space here, right? So half of 9 is going to be 4.5 feet. 4.5 feet is the tributary area for G5, and then the overall length of G5 is 14 feet. So let's look, so for the storage space, the live load plus the dead load is 295. So let's find the load on G5. That's 295 pounds per square foot, times what is the square footage of this area that we're looking at? We're looking at 4.5 feet multiplied by 14 feet long, the overall length of the girder. So the tributary area multiplied by the overall length multiplied by 295. So that's going to be a total load of 18,585 pounds on G5. So we know that 1/2 of that is going to be going to G9 at that place where it connects. So let's divide that by 2. 9,292.5 pounds. So that is what our that's what G5 is going to be. So we can put that as a point load here. 9,292.5 pounds. And this is G5. That's the load contribution of G5. And what is the distance of G5 from B3? That is 7 feet. Okay, so now we need to do our moment equation because we want to figure out what is the load, the beam reaction for G9 at B3 and A3. Okay, so let's, since we have to do that, since we're finding both the beam reactions at A3 and B3, let's go ahead and write our equations of equilibrium. Sum of the forces X equals 0. There are no forces on this, so we're just going to call that 0. No lateral forces on this, so we're calling that 0. Sum of the forces Y equals 0. And what are the sources, the sum of the forces in Y? Well, we have B3 plus A3 together have to push up, right, to resist the loads applied to the system, which would be 9,292 plus 12,480. So plus 12,480. That gives us a total of 21,772.5 pounds. That B3 plus A3 have to equal that, right? Okay, and so now let's do our moment equation. And our moment equation, let's do it about point B3, right? And that is going to be, okay, so clockwise, clockwise, and counterclockwise. Clockwise, we call, clockwise we call negative. Counterclockwise we call positive. So since this is clockwise, we're going to say negative 9,292.5 pounds multiplied by 7 feet minus 12,480 pounds multiplied by 8 feet. So this is the load from girder G5. This is the corridor load. And then our stabilizing reaction here is A3 multiplied by the overall distance, which is 16 feet, equals 0. Okay, and now when we crunch this, A3, the reaction at A3 equals 10,305.47 pounds. So we can now plug that in up here to find B3, and then B3 equals 11,467.03 pounds. Okay, so that means that B3, we've got 11,467.03 pounds coming in that have to be supported by the column B3. And at A3, this girder is delivering slightly less force, 10,305.47 pounds here, which has the column at A3 has to resist. Now let's look at our final example, example 7. What is example 7 asking? Let's see, determine all of the loads on column B3. All right, so B3 here, that's the one that we just calculated some of the loads on it from girder G9, right? So we know how many the loads coming in from G9, right? But there are two other girders that come into it, G6, which we've also already looked at, and G14, which we haven't looked at. So let's look at the tributary area for this. So this is column B3 right here. This is the zone that affects column B3. Here are all of the tributary areas, right? We have this girder coming into it. We have this girder under here coming into it, and then we have this girder coming into it. And so here are the tributary loads for all of those girders, including showing this point load here that we just calculated coming from that system. Okay, so calculate all of the loads on B3. So let's see what we've already figured out here. Okay, so the loads we need to know the loads from G6. We need to know the loads from G9, and we need to know the loads from G14. So what are the loads from G6? I think we've already figured that out. So if we go back a few examples to this one, right, we're looking at G6 and the continuous loads on G6. And the load at B3 was 4,777.5 pounds. So this one, 4,776 pounds. Is that right? Or 77.6? 4,777.5. 777.5 pounds. So let's just call that 4.78 kips. All right, now we're concerned also with G9. And G9 we just figured out in the last example, right? It was all of this stuff at B3. So the beam reaction of G9 was loading 11,467.03 pounds. So let's just round that up to 11.47 kips. And now we're concerned with the load from G14. So we haven't figured that out yet. So let's look at the load from G14. So what is G14 supporting? Well, we have a one-way span on this side coming in this way. And we have our two-way span like this that it has to support. So if we look at a quick free body diagram, we've calculated some of these things before, actually. So let's look at B3. It's symmetrically loaded, so it doesn't really matter, but we'll look at B3 on this side and C3 down here. So it's like we're looking at it this way. And the continuous load from the corridor is going to be 195 pounds per square foot. So that's the live load and dead load, multiplied by a tributary area of 4 feet. That's going to give us a load on top of 780 pounds per foot, right? And then we also have our continuous load, which we figured out a couple of problems ago here. We figured out that that was 9,555 pounds represented as a point load in the center of the system. So let's, why is this happening? Let me scroll down here. Okay. So we can just put that two-way span load here. I can get my markup to work again. There we go. So this is 9,555 pounds. This is our two-way span load. And then our 780 pounds per foot, what is this? I think we did figure it out before, but we can figure it out again. This is 14 feet, the overall length of, so our free body diagram here is for G14, and G14 is 14 feet long. So we have 780 times 14 times 4. 780 times 14. That's going to be an additional point load of 10,920 pounds. So if we add our 955 to our 10,920, that's going to give us a total load of, let's see, what is this? A total load plus 9,555. So these two things, the total load is 20,475. And then if we divide that by 2 so that we know what's happening at either end of the beam, that gives us 10,237.5. 10,237.5 pounds on either side of the beam. Okay, so we're just concerned with what's happening at B3. And so let's just round that up to 10.24 kips. Right, and so we need to add up all of these to calculate all of the loads on column B3. So if we add all of these things together, what we get is a grand total of 26.49 kips, which is approximately 26,490 pounds. So that's, I hope these examples give you a good sense of how to work through these problems. If you have any questions, contact your TA or shoot me an email. Good luck with everything. And again, you know, the homework examples should include a 3D framing. Don't get confused with the beams being shown. That's just, these are just shown to help you to understand the way that the directions of the spans are, to help you understand the directions of the spans, but we're really just worried about the green girders and the red columns. And it can be helpful to look at the 3D diagram, but you should also mostly be able to look at the framing plan and begin to sketch on top of it and figure out what's happening. So good luck, and let us know if you have any questions. Thanks.